Hey guys, so today we are going to be doing electron configurations. I just wanted to give you some helpful pointers on this assignment. Number one, you should have your reference tables opened, and then today we're going to be working off of slide 8. So 8 is going to help you a good bit. It's got those S, D, P, and F blocks on there for you. There's also a version in the slideshow from today as well. So I'm just going to go through and point out some helpful hints, and then we will hopefully be able to get through this pretty easily. Now, electron configuration can be tricky. I linked an extra video to another person's YouTube video that's very helpful. She does a wonderful job. It's in the engage portion of your assignment. So if you need just to see it in a different way, I do recommend going back and completing that. So there's just a few slides to complete here today. This one's asking for the electrons each sublevel or orbital can occupy. That's in your notes, so just go back and review that. Remember, orbitals can only hold 2 electrons, so each orbital is going to hold 2, but then sublevels and different energy levels have multiple orbitals, so just go back and review that. Now, you are going to have to complete the electron configuration for 3 of these elements, and I will say right now, if you Google electron configuration for these, it's going to give you something called the noble gas configuration. We're doing noble gas tomorrow. And so if you put the noble gas configuration, I'll know that you have Googled because we haven't gone over that yet. So what I'm asking for here is the full configuration. So each of these configurations should start with 1s. Okay, so 1s. So that's just a little caveat for that. If you Google the configuration for these, it's going to give you the wrong answer. You have to do it. Now, for example, we could do boron together really quick. Let me pull up a P table. This is also linked in your class materials, but it's also super easy to Google. Okay, so boron is right here. Okay, so I'm going to take a look at him. So he has an atomic number of 5. So I know that there needs to be 5 electrons that are filling these orbitals. Remember, A is equal to P is equal to E. You find your electrons from your atomic number. So I know that my superscripts should add up to 5 for boron. So he is in the second row, right? So he's in the second row, second period. He is the first element in the P block, okay? Because remember, if we go back to our reference table, here's the S block and here's the P block. So he's going to be in P block. Remember, the first letter is the period, the second is the block, and then the third is the electrons in that orbital, aka the number of the position in that block. So for example, boron, he's in row 2 or period 2. He's in the P block and he's the first element in that block. So I know I should be ending with 2P1. All right, so 2P1 should be my final configuration for this. But because we're doing full configurations, we have to go through all the other configurations. So we're starting here. Okay, remember, helium is over in the S block. It's just over with the noble gases because it's stable. So we would do 1s2 because we have to go through the first S block, 2s2, 2p1. Okay, so that's boron. So it'd be, type in here, 1s2, 2s2, 3p1. Okay, and if you wanted to make it beautiful, you could make these superscripts as well. But if you are typing it just without the superscripts, make sure you put a space in between them just so it makes it easy for me to grade it. So that would be boron, okay? Another way you could check this is, remember, the superscripts have to add up to the atomic number. So 2 plus 1 would be 5, okay? Another way to do this is to use this chart, this electron configuration chart. So in the notes today, I showed you how to do it the long way, aka from the periodic table, but you could also use this chart. This shows you how the energy shells fill, and if you can remember that S's contain 2 and then P's contain 6, then this is going to make your life a lot easier, right? So you can use this. It shows you the way that they fill. You would just follow this, through until you get to the number of electrons that you have in your element. So like for example, I know that boron has 5 electrons, so I could just start here and start to fill until I get to 5. You just have to kind of remember how many you're counting up to. So it'd be 1s2, that's 2 electrons. Then I would follow, it goes to 2s2, that's 4 electrons. Then I get to my 2p, I only have 1 electron left. P could fill up to 6, but I'm only needing 1 because there's only 5 electrons, so it would be 2p1. Okay, it's a little cheat sheet that you can use. Either way, you're going to find the correct answer, whichever is more intuitive for you. I always teach it the way with a table, but you can use this little chart as well. Okay, so there's that one. And then for these, you have to write the symbol of each neutral element based on its written electron configuration. The easiest way to do this, a little bit of hint, is that remember the superscripts have to add up to the atomic number, right? Because the superscripts are telling us the electrons that are in this configuration. So you could do this one of two ways. You could add up the superscripts, so 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 10 plus 6 plus 1, and then you could find the atomic number that has the sum of all of those, or you can just use the last position of the configuration, so 5s1. So 5s1 I knew would be period 5, block S, first position, that's rubidium, which is Rb, so I'm going to type in Rb for that. Okay, so, and then you could also double check too, like if you're using the position, you can add up the superscripts, which then will give you the atomic number. And then same thing for this, you are literally just trying to identify the element here. So you're adding them up, or you're using the final position on the table to find the element. Okay, remember if you add the superscripts, it gives you the atomic number, or you should know how to find the position with the electron configuration. There are a couple of these on here that students Google. I think for some reason, I think it's this one, the second one here on the yellow one. A lot of, it happens, students Google things and it gives you the wrong answer. Okay, you cannot, electron configuration, pretty much anything in chemistry, you cannot Google it because there's so much upper level stuff that could also pop up, like organic chemistry, college level chemistry. Don't Google it. Just use the information that I've given you and you'll be okay. Okay, so this one is the same exact as the green one. You're just using the position to identify the element. You can double check by adding up the superscripts to give you the atomic number. Okay, if you have questions, please come to office hours. Like I said, I know this can be tricky, but you guys can do it. Okay.